Okay, what is trig? Okay, so it's called trigonometry. And it stands for triangle measurements, or triangle measures. Okay, so what we're going to be focusing on for our class primarily is we're going to be focusing on right triangles. Okay. If you have a right triangle, you know that no matter what, this is the hypotenuse. That will never change. The hypotenuse is always opposite the right angle. From there, we have other relationships. So let's say that we are talking about angle R, angle S, and angle T. And let's say that I have some of my measurements, but I need more. I can use trig to find the remaining measurements of my triangle, whether it be angles or sides. So first of all, we're going to get used to the trig functions and where they come from. We have what is called the sine. Now, you do not say sin, it is actually sine, but on your calculator you will see sine. You'll also talk about cosine, which on your calculator you will see cos. You do not say cos, you say cosine. And then we have tangent, which on your calculator you will see tan. When you are starting with sine, cosine, and tangent, you need to understand where these relationships come from. So if you have the sine of some angle, we're going to call it theta for right now. So the sine of some angle theta equals the length of the opposite side and that is the ratio of the length of the hypotenuse. Okay, and again, we'll go into more details with this as we go. Cosine of some angle is equal to the length of the adjacent side set up as a ratio of the length of the hypotenuse. And the final one that we are going to work on is the tangent. And the tangent equals the length of the opposite side over the length of the adjacent side. Okay, and you're thinking, how in the heck am I ever going to remember that? Well, we have what's called a little phrase, and it is Sohcahtoa. Sohcahtoa. That's going to help you immensely. It sounds corny, but it does work. That means the sine is the opposite over the hypotenuse. Sine is the opposite over the hypotenuse. Cosine is the adjacent over the hypotenuse. So the cosine is the adjacent over the hypotenuse. And then finally, toa is tangent, opposite over the adjacent. We have the tangent and opposite over the adjacent. Now, like I said, the hypotenuse is never going to change. It is your opposite and your adjacent that are going to vary. So I'm going to go back and I'm going to draw that same triangle I just had, just because I ran out of room. So we had R, S, T, and I knew that And I knew that this side had to be the hypotenuse. The adjacent and the opposite are determined by where it is, if you will, where you are standing. So if I'm standing at angle T, well, we have opposite, or we have the adjacent. So if I'm standing at T, the side that is opposite where I'm standing will be right there. The side that is adjacent to me, or what I am touching, is right there. Now, if I were standing at a different angle, so if I was standing, oops, that's a T. So if I was still standing at R now, this is still and always going to be my hypotenuse, but now ST is going to be my opposite, and then RS would be my adjacent. Okay, so if I have a triangle of, let's create some new letters here. If I have M, N, and P, and I'm just looking for the ratio. So I want the sine of M. And let's see, let's just put some numbers in here. Let's do a 5 and a 12 and a 13. Okay, so sine of M, I need to remember Sohcahtoa. Sine, so I'm focusing on this one, of M. So that means I am standing at M. That is the opposite over the hypotenuse. 5 would be the opposite, and the hypotenuse is always the hypotenuse, is going to be 13. Now we will do more with this a little bit later, but right now we're just writing the trig ratio. So what is the cosine of M? Okay, I'm still standing at the same angle because that's what I'm looking for. So the cosine of M is going to be the adjacent over the hypotenuse. So the adjacent would be 12, and the hypotenuse is going to be the 13. Tangent of M, tangent is going to be the opposite, which is 5, opposite side, over the adjacent side, which would be 12. Now I'm going to throw something out there. What would the sine of N be? What would my ratio be there? Okay, so the sine of N. So now I need to kind of get rid of my little dude standing there. Now I'm going to be standing at N. Sine of N is going to be the opposite, which from here is going to be the 12, and my hypotenuse, which is the 13. So you'll notice that the cosine of one angle and the sine of the other one equal each other. Cosine of one angle and the sine of another angle equal each other. That should be a good start to Sohcahtoa and just understanding the basics of opposite, adjacent, and hypotenuse.